The Voyager probes represent one of the most extraordinary and forward-looking success stories in the field of space exploration. Launched by NASA in 1977, the twin probes, Voyager 1 and Voyager 2, were designed with the ambitious goal of exploring the outer planets of our solar system, including Jupiter, Saturn, Uranus, and Neptune. No one could have predicted how far they would travel or how long they would remain operational. What began as a 5-year mission became one of humanity's longest and most remarkable endeavors, with the probes still transmitting scientific data decades after their launch. Even today, after nearly 50 years in space, the Voyagers have ventured into interstellar space, beyond the reach of our direct influence, setting yet another milestone in space exploration. The primary objective of the probes was to explore the outer planets of the solar system, collecting detailed information about these distant worlds. Voyager 1 and 2 astonished the scientific community with unprecedented images and discoveries that forever changed our understanding of these planets. Jupiter, with its massive storm, the Great Red Spot, and its numerous moons, including Europa, a frozen moon harboring a liquid ocean beneath its icy surface, has been studied for decades. However, it was through the Voyager probes that we first observed it up close. Details about atmospheric storms, planetary magnetism, and its moons were revelatory. Similarly, the images and scientific data about Saturn, its rings and moons like Titan, which has a dense atmosphere rich in methane, were fundamental in advancing our understanding of planetary chemistry and dynamics. One of the mission's most remarkable achievements was Voyager's approach to Uranus and Neptune. Voyager 2 is the only probe to have visited these two giant planets, transmitting detailed images of their rings and moons. The discovery of Uranus's tilted magnetic field and Neptune's violent storms and high-speed winds provided scientists with insights into these mysterious worlds, helping to better understand the characteristics of giant planets. These findings also shed light on the dynamic processes of outer planets and their atmospheres. In 1990, just before Voyager 1 exited the boundaries of the solar system, it captured one of the most iconic images in the history of space exploration, known as the pale blue dot. In this photo, Earth appears as a tiny blue speck in the vastness of space, a perspective that profoundly impacted our understanding of how small and fragile our home is in the cosmos. This image became a symbol of humanity's vulnerability and connection to the universe, evoking a sense of humility and responsibility for our planet. Carl Sagan, one of the most renowned astrophysicists and an enthusiastic advocate of the Voyager missions, interpreted this image as a reminder of our place in the universe and the need to preserve Earth as our only refuge. Since 2012, Voyager 1 has crossed the boundary of our solar system, officially entering interstellar space, a region beyond the influence of the solar wind emanating from our sun. Voyager 2 followed in 2018. Both probes are now beyond the solar system, transmitting data about a region never before explored. Interstellar space, the vast emptiness between stars. By studying plasma density and cosmic particles, the Voyagers are providing essential information to help scientists understand the nature of this uncharted environment. The mission has opened a new chapter in space exploration, offering scientists the opportunity to observe an aspect of the universe that was previously beyond our reach. Challenges, however, have not been absent. Despite technical difficulties and the ever-increasing distance, the Voyager probes have continued to operate, demonstrating extraordinary resilience. Their longevity has been made possible by the robustness of their systems and NASA's ability to promptly address malfunctions. One significant example occurred in 2022, when Voyager 1 began transmitting incomprehensible data. The probe's orientation system mistakenly attempted to send data through an inactive pathway, causing the malfunction. NASA engineers were able to diagnose and fix the issue, allowing the probe to continue its mission. This is just one of many instances where, despite hardware failures and communication problems, the mission has persisted thanks to the engineers' interventions. In 2023, another issue arose with Voyager 1, where its transmission system began sending only sequences of zeros. This malfunction was linked to a defect in a microchip, requiring engineers to devise creative solutions to bypass the issue and restore data flow. The intervention involved intense coordinated effort, given that the probe is now more than 22 billion kilometers from Earth. Thanks to NASA and its team of engineers, the problem was resolved, but the incident highlighted how fragile and challenging it is to maintain space probes at such distances. The primary challenge the probes now face is their energy supply. The Voyager probes are powered by radioisotope thermoelectric generators, RTGs, which convert heat from the decay of radioactive isotopes into electrical energy. However, over the years, the power generated by these generators has progressively decreased, requiring the probes to manage energy with extreme care. Each year, the probe's energy capacity diminishes, and engineers are forced to systematically deactivate non-essential instruments to keep the most crucial ones operational. For example, in 2024, one of Voyager 2's scientific instruments, the plasma sensor, was deactivated, as it no longer serves a relevant function now that the probe is in interstellar space. These decisions are difficult because turning off a system means losing scientific potential. However, NASA has managed to maintain a balance, prolonging the mission far beyond anyone's expectations. Despite all the technical difficulties, the Voyager probes continue to traverse space, gathering information about a previously unknown region of the universe and making history. What began as a relatively short mission has become humanity's longest and most fruitful journey of space exploration. The probes will continue transmitting data as long as their energy allows, and once their power is depleted, they will still journey through space, carrying with them a message from a civilization that dared to look beyond its own world. The Voyager probes are not only a testament to human engineering, but have also become symbols of exploration, curiosity, and the unending quest for knowledge, destined to tell our story in the most distant future. Thank you for watching. Don't forget to like the video, subscribe to the channel, and turn on notifications to stay updated on upcoming videos.